Hello, welcome back. I'm Savalian. I make videos about games, development, and creativity, and we're finally back with some game development. I've had kind of a rough year. Some of it is like mental motivation issues, some of it is technical issues, and then some of it is time issues because I've been playing a lot of Pal World. It's important to me. We have so many eggs to hatch. But we're here today to talk about an issue that I ran into with Godot 4, specifically around some of the 3D APIs that they provide for you to access the mesh data. And because I had a hard time finding existing information on some of this stuff, I wanted to make this video to talk about what I was trying to do, the problems I faced, and then how I fixed it, so that hopefully someone else who is encountering the same problem can find what they need. And because I know it can be easier to sort of approach code information via text sometimes, I'm also writing up a Medium article, so I'll put that up hopefully shortly after this video goes out, and I'll link it below. If I forget, please remind me, because I do want to do that. But the basic thing that I wanted to implement was fish. I'm making a fishing game in Godot 4, but I have gotten to the point where I have a fishing system working at a basic level. You can equip a fishing rod, cast it, maybe hook something, reel it in, but what I didn't have was the actual fish. And I had a couple of goals for this system that I knew I wanted going in. One is that I did not want to individually model each type of fish because I am one person. It is time consuming. And if I could find ways to reuse assets and still get the variety that I want, I'm gonna do that. Another thing that I really wanted that's a little bit harder to accomplish is variety within the types of fish. So, for example, goldfish, they all kind of look similar. They're sort of little, round, but some of them are bigger, some of them are smaller. And I think I'm running out of battery. Okay, camera died. I don't think I've used it since the last time I charged it, so I'm a little concerned about its battery capacity, but we can continue with the streamer camera, and I think it'll be okay. So where was I? I was talking about the requirements I wanted for my fish in my fishing game. I covered the first two. I want different types of fish that I don't necessarily need to model each one individually, and then I also wanted variation within the fish types. Just to make them a little bit cooler. Some fish should be different sizes, slightly different shapes, maybe slightly different colors, because I think this is fun. First of all, it's fun for this to happen, and then also it is a little bit more realistic, which can also add to the excitement of discovering all the different ways the fish can look. And then the last thing I wanted this system to support is the ability to have non-fish catchable fish, or at least fish that are a very different base shape than most fish are. So squids, eels, sharks. I'm not sure how deep I'll go into if I want to include things like crabs or not, but I want the ability to add things that are a drastically different shape and still have those same capabilities within those types of fish. So knowing all of this, what I wanted to do was first I wanted to use the same UV sliding method that I've been using for a while. I've talked about it a lot before, but basically instead of painting individual textures for each mesh, I unwrap the faces of a mesh onto blocks of color on a texture. It kind of looks like a texture atlas. And that makes my modeling process much quicker, and a bonus is that if I slide the UVs to a different block of color at runtime, it will change the color of the object. And then what's really exciting is that I wanted to use blend shapes, which are a thing that I've been excited about for probably 10 years. I've never really had the right opportunity to use blend shapes in a game. If you've never heard of blend shapes, they're also called shape keys or morph targets. I'm not sure if there's any other names for them, but those are kind of the main three. And what they are is basically you have a mesh. Often it is like a character mesh, like a face. And then part of that mesh you will add a new blend shape for. Let's say you make the head really wide, and that's the second shape. So you have the same mesh, but it's in a different position, the vertices are in a different position, and then you can blend between those two states evenly so that each vertex will move to its new position. And that's how you get things like character customization sliders, where you slide it and it like expands the nose or makes the arms and legs longer, something like that. That's typically how it's done. And I wanted to use blend shapes for the shape of the fish, and then that way I could define different shapes that each fish could be. I only have to make one model, and then I can create a lot of different shapes of fishes. And then on top of that, I can add the colors. And then I'm not going to talk too much about this in this video, but I can also sort of modularly add different fins, different tails, different like dorsal fins. And all of this combines together to create a pretty versatile fish customization system. The first of its kind. I actually don't, that's probably not true, but I'm very excited about it. And the trick that I ran into with Godot 4 when I was trying to implement this, and I'll just explain this now so you don't even have to watch the rest of the video if you don't want to. The trick is that when I was copying out the array mesh to create a new instance that I could adjust the UVs from, it was not also copying out the blend shape information. So what I had to do, and it took me a while to figure out what was happening because the errors were referencing blend shapes, but it wasn't really clear what they wanted me to do. What I had to do was when I was copying out that mesh data, I had to individually copy out the data for each blend shape and apply that to the new array mesh as well. So hopefully that helps if anyone was here just for that. But I'm going to go through my whole process of setting up my fish model, creating some code to store data for like how I'm going to build out and render these fish. And then I'm going to go into the UV sliding code and then also the blend shape code, which is fairly simple. And then I'm going to show you the end result, which is basically a system where I could just plug in some numbers and get out of a random fish, or not so random if I have a specific type of fish that I want to render. So we're going to get into the code and I'm going to walk through all of it. Okay, so we start with the model of the fish, and this is going to set up the UVs and the blend shapes correctly. And I'm not going to walk through exactly how to add blend shapes and how to do my UV method because I have other videos about the UVs at least, and then I know there's lots of information about blend shapes out there, but I'll cover the basics. So what I did at first was just model a fish in sort of what I would say a neutral configuration. So like on the smaller side, just sort of a general fish shape. And I also modeled the fins, I don't know what these are called, the arm fins and the dorsal fin and the tail are all separate objects. And that's going to be so that I can come in here later and I can either hide or delete the ones I don't want and then add ones that I do want. And then the fish will have different fins and they'll all be configured to this shape so that I can just sort of swap them in and out. And this is how a lot of like armor equipping systems are done, is that they're actually just like separate model pieces modeled onto the main piece. But once I have the general fish shape, I can't remember if I did UVs before or after the blend shapes, but at some point I do come in and I unwrap the parts of the fish onto this texture, this is my current lazy UV texture. I think I'm going to change it because I think I want one that has a lot more hues for fish specifically. In my last game, I used the same texture for all the objects in the game. And for this one, I think I want to do it differently where I have just one big fish texture. I think it'll make things a little bit easier to manage, but that's beside the point. But once you unwrap each piece of the fish onto these colors or these gradients, you can see them show up on here. And it looks kind of weird because I have, in edit mode, I have a blend shape activated, but don't worry about that for now. Back to sort of our basic fish here. Once you have your base model, the way that you actually do add blend shapes is in the like vertex data tab here. And they do call them shape keys here, which is making me wonder where I heard the name Blendshapes, because I learned to use them on Blender. Anyway, this is important, actually. This is very important. Before you begin adding shape keys or blend shapes, you will want to apply modifiers. Like if you have a mirror modifier, you will want to apply that before adding shape keys, because it won't tell you this until you try to export it, but shape keys cannot be sort of applied on top of modifiers. And so I believe I did have to go back, apply the mirror, and then redo some of the shape keys because I messed that up. And this is a lesson I've learned the hard way several times. I just keep forgetting. So I'm telling you now, apply your modifiers before you add shape keys. If you need a backup, save a backup before you do that. But it will give you a lot of trouble if you don't do this first. But basically you have a basis shape key. And I believe when you add the first one, it will add that basis for you. So then to get an additional shape key, you do need to press plus again. You can name it. I've named this one body length because guess what? When you increase the value, it increases the length of the body. And you'll notice that the fins are not moving to match the new body shape. And I'm going to talk about that. But basically, once you add a shape key here, when you go into edit mode, you can adjust the shape of what that blend shape looks like. So here I've just made the fish long. That's all. Body length, make it long. And I've found that blend shapes often work best if you sort of start from the minimum as your basis and you work to the maximum. You can do things where you have like a neutral basis and you make them smaller and then you make them larger. But because you can apply multiple blend shapes at once, this gets a little hard to manage as you have a more complicated set of blend shapes if you have them going sort of in both directions, like bigger and smaller. So that's just something that I like to do. You can, of course, do things however you like, but basically you just go into edit mode, you adjust the shape, the new shape, however you want it to be. But what I have here is I have body length, which is the long one, and then I have body width Y. I'm going to add a body width X. That's going to make them fatter this way, but for now these are the only two I have for testing purposes. This one increases the width of the fish this way, and it could probably be a little bit more extreme, honestly, now that I'm looking at it. And now I'll talk about how I've done the other pieces. So basically, in order to keep this modular setup, but also have things look correct, you can see I've added the same blend shapes to each one. And as long as you have this, like, you know, for example, body width Y at full power, then I go into here, you know, it starts in this position. I went into edit mode and I moved them so that they were positioned correctly on this new shape. So now when I tweak this to full, it matches. And then also if I go, if I can type, if I go to half strength on both of them, you can see it also matches because I've made them match at the minimum and the maximum, and they both blend linearly in the same way. So we have basically eyes that always sit on top of the head here where they go. I've also done it with the dorsal fin here. So if I turn this up, what was it, 0.5, you can see it fits here. And so that's how I did. It's a little tedious to set this up, but once you set it up, you have a pretty flexible system where, for example, if I set body length also to like 0.6, then I can do this one, 0.6. So you can create a lot of very interesting shapes, and it really didn't take very much time to set this up at all. Now I'm going to set all these back to 0 so that I don't get confused later. So this is our fish. We've got the UVs set up. We've got the blend shape set up. I've exported it with GLTF, and I don't believe there's any sneaky things in here. Let me just check real quick. You do need to make sure shape keys are checked, which I can't remember. I think they are checked by default. I could be wrong. I don't export materials. You can if you want. But I believe all of the other export settings are pretty normal. So so I'm not going to talk too much about those. And then we're going to head over to Godot. So in Godot, I just import the fish. I don't believe I needed to change any import settings, but in the end, I have this fish here. It's got the skeleton in there. You can see it's got all the different pieces for the different parts of the fish, and I can access these individually in the case where I want to disable them or swap them out. This fish doesn't have eyes, maybe. And then I also have the animation player here, but it doesn't, I didn't make any animations that I exported yet. Or did I? No, I did. I did this one. He swim. It doesn't loop, apparently. I must have done a re-export. That's the one thing I do have to adjust in the import settings, is the looping. But I'll fix that later. So I have the fish model in Godot, and then I had to start thinking about how I'm going to define these things in code. So I started with a very simple data class called fish data. And all this has in here is data for, let's like say I have one fish and I want to set the values for the shape of it and the colors of it and the scale of it. This just holds all that information. So I have a reference to the actual fish object that I want to instantiate. This is how I'm going to get like squids and sharks and maybe crabs in the scene, as I'm going to have different prefabs for them. And then I have the blend shapes. So blend shapes are essentially a value from 0 to 1. So I have float, body length. I added BS for blend shape here. I don't know why I didn't add it to this one. Body width Y, and then I have color indices. And these indices refer to the position on the UV texture. And then I just have an overall scale to make the entire fish bigger or smaller. And then on its own, this doesn't actually do anything because we need to actually use these values once we create them. So I also have, this is where we get into the, oh, and sorry, I forgot to make the code bigger. Here's a look at the data class up close before we move on. Don't worry about the code that's over there right now. But yeah, here's the prefab, blend shapes, color indices. All these are sort of just initialized to 0 values. But like I said, this does not do anything on its own. This is just a data class to hold information we can pass to other functions. So next I added the fish updater script, and this is where we start to actually do things with the code. So this is a node, so this goes on the fish object, and basically what we do here is we pass in that fish data object, and then we do things to make the fish render out the way that it's supposed to look. So starting at the top here, the very top, first we need references to all the meshes so that we can adjust the UVs and the blend shapes on them. So that's a mesh instance 3D, and I do all of this in C#, at least right now. I've considered moving to GD script, but I haven't made that leap yet. So all of this is going to be in C#, but you should be able to sort of see what it is and convert it if you really need to. And then in the ready function, this is necessary because of how 3D objects work. And I think most engines, but definitely Godot 4, which is that if I were to, say, put several fishes into the scene, all of their mesh data is sort of connected. They're all spawned from the same original scene. And in order to be more performant, it doesn't create a whole new copy of all the mesh data. It reuses it. So if I adjust that, I change the UVs of every fish in the scene. So in order to get a new copy here, we'll get into this this function in just a moment, but I have this parameter at the end, which is create new, and this is what we're gonna do. We're at the very beginning, after we instantiate this fish, we're basically copying the mesh data into a new mesh so that we can change the colors and it won't affect any pre-existing fish. But in this ready function, we do that for each new piece here. And I have these print statements in because I was having a little problem, but I don't need them anymore, so I'm going to take them out. And if I do add other fish types with different like modular pieces, I will need to rework this so that I'm accessing the right stuff, basically. But for now, we just have this one fish with these different pieces on it. And then when I get that newly created mesh data, I just assign it to the mesh property, and that's what creates that new instance. And down here is the code that we call when we actually want to change the fish data and have it change what the fish looks like. So first we have scale. We just get the parent object of the fish, and then we just scale it to the new scale. Pretty standard. And then for each of these objects here, we set the blend shapes. And so you'll see all of these different objects get set to the same values. So like I was showing in Blender, we want all of these to match across all the objects because that will make the blend shapes actually look correct. They will line up in the view if they're all the same value. And this is all you need to do to set a blend shape on an object. You need access to the Mesh Instance 3D. That's what this is. Mesh Instance 3D. And then you call set. And then the property path, at least for me in this version of Godot, was blend_shapes / and then the name of the blend shape as it's defined in the mesh data. So body length, body width y, and then the value we pass in is the float value from 0 to 1, what we want to set that blend shape to. So we do this for both blend shapes, and then the recoloring happens after that. So that's really all we do. We set the blend shapes, we set the scale, we set the color for each object, and that will propagate all the changes that we want. So now we're going to look at the UV sliding. So here is my UV code. I've made this static so that I don't need to like create a singleton of this UV utility because it doesn't really hold any data. It just takes in a mesh, changes it, passes it back out. So this is a good candidate for a static function. And this returns a new array mesh, or it returns the changed version of the existing array mesh. And then it takes in an array mesh of the object of the color that we want to change the color of. And then we have which row we want to move. And I use this so I can have one model with different parts of it on different rows and only slide one of them. I might change this for the fish because of how I've sort of architected each piece to be one color, but I'm still deciding. But for now I have which row to change. If the UVs are not aligned with this row, they will not be moved to a different column. And then I have the column that we want to change them to. And then I have that Boolean. If this is true, we will actually create new mesh data and pass that back. Otherwise, we'll just update the data that was passed in and we won't create a new array mesh. So regardless of what we're doing, we do need to get the data out of the array mesh. And the way that you do this is in order to get the arrays, which these include things, here we go. These include things like vertices, normals, UVs, etc. that make up the requested surface, blah, 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 that make up the requested surface. So they've just got this right in here. This is all the meat of the mesh. It tells you what it looks like in code. And I'm not totally sure when objects have multiple surfaces, but I've passed in 0 here and it seems to work for what I need. So maybe if you have more complicated meshes with like sub-objects, perhaps they would have multiple surfaces. I don't know. I expect I'll run into whatever this is when I least expect it and have to deal with that. But we do surface get arrays, pass in the index, which I'm passing in 0. And then we do need to get the blend shape arrays, which as I mentioned, are stored separately from the vertices, normals, and UVs. And I believe they're stored separately like this because they sort of operate on the other data. So they're not their own set of vertices. It's like a change to the existing vertices. So I believe that's why they have it accessed separately like this. But we do surface get blend shape arrays. We pass in that same index. And then this looks kind of gross the way that it's printed out here, but basically within arrays, the surface arrays, it's just an array of arrays, and each of the arrays in the arrays holds either vertices, normals, UVs, whatever. So to get the UV array, we use this indexing notation here. So arrays, open brackets, and then we have to pass in the index of the array we want, and they've helpfully defined these. So if you use ArrayMesh array type dot text UV, this will give you the index of the UV array. And then I don't remember if I needed to cast it as an int, but I did. And then we want to do dot as vector2 array. And this is a sort of C# specific thing to get this in the format that we're going to be using it in for C#. I believe if you're accessing this in GD script, it looks a little bit differently. But this will just get us an array of vector2 coordinates, and each of those is the UV coordinates of a vertex. Next, we have a variable. This is used for figuring out which color block the UV is inside and how we move it to different color blocks. So there are 20 squares of color on this. And the way that UVs work is that the texture is always square. You always need a square texture. And then it's just 0 to 1. So 1 divided by 20 gives us the UV coordinate distance between each square. And then we just need a new array for the UVs. So we make a new vector2 array, same length as the UV array, so that when we run through this, we move the UVs, we put them into this new array, and we use that to update the values. So here's where we do the work. And I have this I have this to-do comment in here because when I started writing up this video and going through my code and making sure I had everything correct, I realized I never actually implemented the UV sliding correctly. It would just advance the UV to the next step. It was sort of just a make sure this works. And so I had this to do in here because it wasn't actually working. And I thought that was funny. And I just implemented it real quick before I filmed the video. So this is all correct here. But basically, we loop from 0 to the length of the UV array. So we loop through all the UV coordinates. And then the first thing we do is figure out which block this is in terms of vertical space, so which row it's in. And I realized that while Unity's UV textures go from the bottom up, like the bottom is 0 and it goes up, it seems like when Godot does it, they start at the top. So I had set up my texture with this index at the bottom. So I've just added this number here. This is 19 because I have 20 squares. So the indices are from 0 to 19. And here we get the y of the UV coordinate, which really this would be v. You define UVs with u and v as the coordinates, but because they're just using a vector2, it's y. And then we divide that by the space between squares, cast it to an int, and that gives us with the index of which row this is in. And we have the 19 here, 19 minus to just sort of flip that upside down because I didn't realize that that's how it worked. And then here we just make sure if this index is not in the row that we're changing, we don't do anything, we just continue. If it is, we grab the x index or the u index. So we do the same thing here. We get our UV array coordinate, the x value, divide by the space between the squares, cast that to an int. This will give us the index of the column that it's in. And then in order to figure out how far we need to slide it to get it into the column we want, we do column index, which is the desired column, minus the current index or the old index, and we multiply that by the space between the squares. This gives us the slide distance. And then if we are in front of this, so to speak, this will be a negative number, so we'll slide it backwards. Or if it's behind us in terms of, 0 to 19, we'll slide it forward. This also is just some testing code that I no longer need because I got it working. And then, so we have this slide distance. We create a new UV coordinate, new vector2. We do the x value plus the slide distance, and we just pass in the same y value. And that's our new UV coordinate there. We do this, we loop through the entire array, sliding each one as necessary. And once we have that, we access that arrays object again. We use the same index here to get the UV array, and we assign those new values. And then this is where we actually create a new object or not. So if we are not creating a new object, the way that we update those array values is to first clear the surfaces and then add surfaces from arrays. So what this function takes in is first a definition of what kind of primitives we're using. This is probably going to be triangles most of the time. I'm not sure, maybe there's ways to use quads, but triangles is kind of the correct way to do it, and how it gets exported from a lot of 3D software. And then we pass in our arrays, which now has the updated UV coordinates. And then this is where we pass in the blend shape. And if we don't pass these in, it will yell at you. So that's why you needed to grab those blend shape values and get those passed in. And I guess I actually do return null if I'm just updating the existing one, which is fine. I just didn't remember that I did that. So to create a new object, we actually create a new array mesh. And then what we have to do in order for the blend shapes to work correctly is we have to loop through the blend shapes with object mesh get blend shape count, and then we need to grab the name of each blend shape and manually add it to our new array mesh, and then we need to set the blend shape mode because for whatever reason, even though we have this blend shape data here, it doesn't include the names. It doesn't include the names of the blend shape or the blend shape mode. So this step was one of the more trickier ones that I actually had to figure out because in my mind, I had the blend shape data, I was passing it in. It should just work, right? Apparently not. So this step was necessary for me when creating a new array mesh so that the mesh object understood what blend shapes were there. And then from that point, we use the same call that we use up here, add surface from arrays, primitive type triangles, arrays blend shapes, and this will create a new instance of that mesh and we can return it. So that's kind of the bulk of the system here, and I actually created this scene, fish gen scene, and this is the code that sort of runs the scene. I have the fish object and then the updater, which we talked about the fish updater code. And basically it just has one button, and whenever you press the button, it uses random number generator to generate random values for all of the options. I just did all the fins the same color to make it a little bit easier, but we get a random value for the blend shapes, random value for the colors, and then we assign all that to the fish data, and then we update the fish. And I'll show you what that little scene looks like. All right, and so I included this fish here as an example of if I didn't create that new mesh instance, when I change this fish, both of them would change. So I have this as a sort of proof that they are separate instances. I hit the fish button, I get a new fish. And the colors are randomly generated each time. And also the sizes, obviously. And it's kind of hard to see the Y width in action because we are sort of facing the back of the fish, but that blend shape is working as well. So there we go. This is how I've sort of built the system that allows me to have all these different kinds of fish, different shapes, different sizes, different colors. And then I can just keep expanding on this to add more variety as I go. And I'm going to talk very briefly, because this video is getting kind of long, how I assigned fish types to the fishing node. So how do I decide what kinds of fish look like what and which nodes that they can come out of? So I first defined this script called fish type resource. And this is a Godot resource, so you can create it at design time and use it to sort of hold data about the way things are defined. And this has a lot of stuff in here, but basically it has the name of the fish type, the prefab we're using, and then it has min and max variables for all the different options for sizing, and then it has an array of possible color indices. So I've defined a couple of these, and the way that this looks here is first I have the prefab in there. I've called these fishes big red fishes, and then the scale is on the higher side. And then all of these variables are also on the higher side. So it's at least 0.5 up to 0.1 for both the length and the width. And then a lot of the colors here, you can't really see it because you can't really see the colors because they are just numbers. These are all reds and pinks, and I've done that for each of the different color areas. So what this will do is it will pick randomly, but only between these values. So all of these fish will be larger, and they will be either red or pink in color. And then I've done another one right here where they're smaller, so down to 0.1 to 0.5, and then 0 to 0.25, so very small fishes. And then the colors here all reference like blues or teals. And so when I generate from these values, it's going to create a little fish that is also blue. And the way I can use these variables here is to adjust the ratios of the sizes to get the shape that I want. So for example, if we want like a long skinny fish, maybe like a sardine that's very small, we can add body length blend shape so that this value is at a minimum, maybe like 0.8 up to 1, and then the size is very small. So it's always long, but it's also very small. And then I would do like a blue or a silver. I think that's what color sardines are. I'm not totally sure. I'm not a fish expert. And then if I want something like a red snapper, I would just want to make sure that the Y width, or the width from like the top of the fish to the bottom of the fish, is very high, because they're like, at least my knowledge from Animal Crossing, they're like a very vertically wide fish that's very narrow along the sides. So I can tweak these values to create the shape that I want, and then every time it generates one of these fish, it will be kind of the right shape, but it will be just slightly different. So once I've defined the fish resources, I additionally have the node resources, which really just it lets you assign the fish resources. So I can assign this then to a node, and then it will pick, sort of which fish resource it wants to use. It has a minimum and maximum fish amount. That is also, all of this is a little bit tinted with randomness, because I think that adds just a bit of flavor. So we have randomness, but we also have these limits. So it gives some shape to the randomness, if that makes sense. So in the end, what it looks like is this is the wrong scene. So in the end, what it looks like is this. Okay, hooray, I fixed a little bug that I just encountered now. Basically what was happening here, and I've encountered this issue in a couple other places. I really need to start thinking about this from the beginning. But what was happening was, in the fish updater, I previously had the ready function create the new meshes, as I think I just mentioned earlier in this video. But the ready function was not completing before I was updating the fish. So I've changed it here. Instead of separately doing it in the ready function, I'm just going to create the new mesh instances the first time we update the fish. So I've got this private variable, created mesh instances, which starts at false. If this hasn't been done yet, we pass in true to all of these UV recolor functions. And then if we do get a value back instead of it being null, we just assign that to the mesh. So we're doing the same thing, we're just doing it in a different place. And what we have here is a working fish generation system. So you can see the red fish nodes have larger fish that are either pink or red. And then the blue fish nodes have more fish. I can't get a great look at them. They have more fish, and they are all like a blue or a purpley color. And that's what we wanted to happen. There, you can see them in there. I don't know, maybe I'll need some way to sort of zoom in on the fish nodes, or just make them bigger overall. But we did it. A little hiccup there with a bug that I found at the last minute. Also, here's a bug. I have some little island pieces I can't even get to because I'm not checking for that in my procedural generation code yet. But there we have it. We're generating these fish nodes with specific types of fish that are all just a little bit different. And I didn't have to manually model each of these separate fish in order to get this working. So once I add a couple more little details, make the fish swim around, show them to you when you fish them up, it's going to be looking like a real fishing game, which is very exciting for me. I'm having a lot of fun tackling sort of the core features first and getting something working. And I feel like we're almost there. We've almost got the main loop done. And then from there we can sort of expand it to be a fully featured game. So that's all I've got for today. Sorry if it was a bit long, but I hope it was useful, and I hope anyone else out there who's having some of these problems with Godot where the documentation is accurate, but it's just missing a little bit of context and a little bit of like sample code for very specific use cases. I hope this helped. And if you liked it, please give the video a thumbs up and subscribe, because I'll be back soon with another video. I think the next video is going to be me talking about some of the drastic measures I took to help motivate myself to work on this game, because I was having some problems with motivation. So subscribe if you'd like to see that video. I'll be back soon, and I hope to see you there. All right. Bye-bye.